In this video, we'll discuss converting between units of measurement. Now, we are going to focus very specifically on the conversions from US to metric or metric to US, which means we will very carefully use these three connectors to help us do our conversions. So when we're converting, we first will have to determine which of those three relationships is needed to help with the conversion. We can use proportions or chain of movement to help us with that conversion. And those estimates that we've talked about before can help us to make sure that our answer seems reasonable. Always pay attention to your significant figures or where you're told to round at the very end. Don't round until you're at the very end. So let's look at the idea of converting 3 meters to yards where we're rounding to the hundredth at the end. So first, I don't have a direct relationship between meters to yards. So I have to ask myself, well, how can I connect that metric measurement to the standard measurement? And what I know is if I look back is that there's 2 and 5,400 centimeters in 1 inch. So if I think through a chain of movement starting with meters, meters can convert to centimeters. Centimeters now can convert to inches. And depending on how you want to go, inches can go directly to yards. So I'm going to start with my meters. I have 3 meters and I make it fractional form to make the chain of movement easier to do. Then I know there's 100 centimeters in 1 meter, which simplifies my units of meters. Now I know that there's 1 inch to 2 and 5,400 centimeters, simplifying that unit of centimeters. And lastly, I know there's 1 yard in 36 inches. This leaves me then with only 1 unit, yards. So I'm going to multiply my numerators and then multiply my denominators, leave me just with my unit of yards. And when I divide this, I will get a very long number, but I only care about now rounding this final solution to the hundredth. And here that's 28 hundredths. Looking to the thousandth, I'm going to keep it as it is. So I would say 3 meters is about 3 and 28 hundredths yards. And that makes sense because our estimate is that a yard is a little less than 1 meter. Now, there's a very common misconception when paying attention to the length that students will treat the US system as if it's base 10, and it's not. You have to pay attention to those relationships and use the conversions that we know. So for example, if I ask you to convert 6 feet 4 inches to feet, and we're going to round to the 10th, a common misconception is the students will say that's 6 and 4/10 feet. It is not. And why? Well, a foot is not equal to 10 inches. That's what a solution of 6 and 4/10 would assume. Instead, we have to convert the inches over to feet and then add it on. So I'm going to use a proportion here. If I use inches to feet equals inches to feet, I can then solve my proportion because there's really 12 inches in 1 foot. So I cross multiply, divide both sides by the 12 inches, and that will simplify my unit of inches, leave me just with feet. And 4/12 is 1/3, which is repeating threes. But it says to round to the 10th, so I would say that 6 feet 4 inches is approximately 6 and 3/10 feet, not 6 and 4/10. Now, when we go to converting areas, we have to pay close attention that we're converting the entire thing by the square because the units are now squared. Often students will say that since 1 foot is 12 inches, 1 square foot must be 12 square inches. That is not true. Let's look at why that would be inaccurate. So here is 1 square foot. Now let's think about converting that to square inches. So if I'm going to convert the 1 foot for my left side, that would make 12 rows of 1 inches. Now I'm going to convert my 1 foot from the bottom. That's going to make 12 columns. And if I look, how many squares are now in there? It's 12 by 12, which is 144 square inches, not 12 square inches. And the reasoning, if you want to think about it another way, is that 1 square foot means that I'm going 1 foot by 1 foot. If I convert each of those units over to inches, that becomes 12 inches by 12 inches, which is 144 square inches. So when we convert to area, we can either determine the overall area and then convert to whatever unit we may want to go, paying attention to those square units, or we can convert each length and then determine the area, just like what we did a second ago. Now, volume will work the exact same way, just you're now going to be dealing with length, width, and height. So you're going to be doing cubic units. So you just got to add in that extra dimension when making your conversion. So let's convert 2 square feet to square centimeters and round to the nearest whole number. Let's take that first option. This is an example of what it would look like. It'd be a 1 foot by 2 foot rectangle as a way to think about 2 square feet. So as an area, I want to then convert square feet over to square centimeters. Well, to do that, I need to go from feet to square inches, and then from square inches to square centimeters. So I still have to follow that chain of movement using the connectors that I have. So I have 2 square feet. If I'm going to convert then to square inches, I know that there's 12 inches in 1 foot, but the way to think about this with the units here is that it's 12 inches squared to 1 foot squared, because 1 times 1 is 1. So I'm going to simplify that out. That's 144 square inches. Now I'm going to convert from square inches to square centimeters. Again, 1 square inch would equal the quantity of 2 and 5,400 centimeters squared. So 2 and 5,400 centimeters become squared is 6 and 4,516 10,000ths square centimeters. Now I can multiply my numerators and denominators because I'm only left with 1 unit. And when I do that, I'll get 1,858 and 608 10,000ths square centimeters. But I'm rounding to the nearest whole number, so that means that 2 square feet is about 1,858 square centimeters. But I don't round until the very end there. Let's look at the other way of doing it as well. Here, instead of dealing with that whole square units that I have to do through the chain of movement, I'm going to change each length to start with. So if I think about changing the 1 foot, I'm going to go from foot to inches to centimeters. So I have 1 foot over 1. I know that there are 12 inches in a foot, and I know there's 2 and 5,400 centimeters in an inch. Again, I'm left with only my unit of centimeters, so I'm going to multiply through, and that's 30 and 4,800 centimeters. So I'm going to replace the 1 foot with that centimeter. Now let's do it for the 2 feet. So I got 2 feet to 1, again 12 inches in a foot, and 2 and 5,400 centimeters in an inch. I multiply across here, and that's going to give me 60 and 9,600 centimeters. So now I'll replace that, and I can say, okay, now since I'm looking at the square centimeters, I can multiply them to get the overall square centimeters. So 2 square feet will equal 30 and 4,800 centimeters times 60 and 9,600 centimeters, which becomes again the same value, 1,858 and 608 10,000ths square centimeters. I'm rounding to the whole number, so I end up at the exact same place regardless of whether I use the first or second option.